So I want to go over one more if statement example. So here I have a problem where it says the following equations can be used to determine the roots of a cubic polynomial written in the form, etc., where a sub n are the cubic coefficients. So let's assume that the coefficients are input as a vector like this. You can see here in my program, I have my vector, 1, 2, 3, 4 coefficients for a cubic polynomial. And then the roots are going to be also a vector that I calculate, x1, x2, and x3. So I initialize them as a bunch of zeros. And then I have a bunch of equations, and each set of equations is under a different scenario. So these three equations, or these 6 sets of equations, or 6 equations, these are always going to be calculated. So I already have these written out. So here's my calculation for A, B, C, Q, R, and D. My next set of equations, we can see, depend on my value for D and my value for R. And there's various scenarios. So this is where we might need to use an if statement. So if D is greater than 0, calculate these. If D is less than 0, calculate these. If D is equal to 0, calculate these. Okay, so once again, thinking about how many options I have. For D, I have 3 options. It's either greater than 0, it's less than 0, or it's equal to 0. So I write my if statement. So first instance, if D is greater than 0. Else if D is less than 0. And then I don't need if D is equal to 0 because my only other option is it for B to be equal to 0. So I'm just going to have an end. Okay, so here's my first set of if statements that identifies what my D value might be. So I have 3 options: D equal to 0, or D greater than 0, D less than 0, and D equal to 0. So if D is greater than 0, then I am going to do these calculations. So they're listed out here, and they look like this. There we go. So there's my if D is greater than 0, I want to do these calculations. So my if statement is only going to do these if D is greater than 0, and then it ignores everything else. Okay, so let's get into if D is less than 0. So if D is less than 0, I'm in this block here. So if D is less than 0, I have a different set of equations to calculate. And those set of equations are dependent on R. So now I have if D is greater than 0, if D is less than 0, and now I'm determining if R is less than 0 or greater than or equal to 0, the other way around. So now I need another if statement that helps me make a decision based on whether or not R is greater than 0 or less than 0. So once again, I just have a new if statement. So if D is less than 0, then I need to check the value of R. So if R is greater than 0, else R less than or equal to 0, and then an end. So now I have 2 options: R greater than 0, R less than or equal to 0. So I have an if and an else, because if it's not greater than 0, it's less than or equal to. And then I can put in my calculations. So if R is greater than 0, then I calculate my value for theta. If R is less than or equal to 0, I have a different calculation for theta. And then I have my calculation for my roots. So pay attention to where things are located. So for this one, if D is less than 0, first I check to see if R is greater than 0 or if R is less than or equal to 0. So I calculate theta. My calculation for theta differs. And then below that, outside of that, I have my calculation for my roots. So my if statement is only used to calculate my value for theta, which is then used to my calculations for my roots. Okay, so these roots do not appear inside of my if statement. I always want them to be executed if D is less than 0. My if statement is only used to do my theta calculation. So there's my second set. Now I want to determine what happens if D is equal to 0. So if D is equal to 0, I'm in this situation, where once again, now I need to decide what to do based on R. So I'm going to have another if statement. So if D equals to 0, if it's not greater than 0 and not less than 0, then I'm going to figure out what to do based on R. So I have if R is greater than 0, else if R is less than 0, and then another else. So we have another set of if statements. So if R is greater than 0, here are my calculations. If R is less than 0, here are my calculations. And then if r is equal to 0, here are my calculations. And then I'm going to display my roots. So here's another if statement that we can put together based on this table here. So we can see how a table, how organizing, what our choices are, helps us directly identify what our if statement should look like. So first, if d is greater than 0, else if d is less than 0, and else. If d is greater than 0, I have my calculations straight up, no other decisions to make. However, if d is less than 0, I need to decide which theta calculation to do based on r. So I have if r is greater than 0 and an else. And then I have the calculations that I want to do given that theta value. And then if d is equal to 0, I have 3 different sets of calculations depending on r. If r is greater than 0, do this. If r is less than 0, do this. Otherwise, do this. I do want to point out that it's important that we test our branches. So I have this that can be calculated, these that can be calculated, these that can be calculated, these, and these. So I have 6 different sets of code that might be calculated depending on what my coefficients are, depending on what these calculations are. So it's important that you identify which code is being tested. So I like to do display statements. So I'll call this branch 1. And then this in here would be branch 2. This in here would be branch 3. Just different sections of code that might be executed. Branch 4, branch 5, and branch 6. So if you want to ever indent your code properly, you can just highlight all of it and press Control I, or this indent option also works. Oh, insert indent, here we go. Here's indent works. Okay, so this set of coefficients, if I run my code, highlights branch 1. So that means this is the only code that's executed inside of all of these if statements. If I wanted to test to see if branch 2 works, I would need a different set of coefficients. So these set of coefficients, when I run my code, highlights branch 2. So it checks to see if this code works properly. For branch 3, once again, different set of coefficients. Run. So here's what it looks like for branch 3. And for branch 4, 5, and 6, same thing. I would need a different set of coefficients to highlight and test those sections based on, because it differs based on what your inputs are. Because different decisions are being made based on your inputs. So it's important that you test all of your sections of code to make sure every single line of code is executed.